So let's just start off with the homework. So, uh, number two and number three were not too bad. Number three, everyone got correct, and as for number two, it's just some careful counting, and the way you ideally want to split up the cases is by the the dimension of the rectangle. So one by one, or one by two, or two by one, or uh, sorry, or one by two, or one by three, or two by three, or two by two. So you could just count those cases and you get 18. So that problem isn't. Those two problems aren't that bad. For number one, several people messed it up. Remember, just remember the concept behind it. So, uh, a game must have two teams. So you choose. There are 16 choices for the first team, and 15 choices for the second team. Alternatively, you can think of it as each team plays 15 different games. However, now you're counting. Either way, you're counting each game twice because one from either side. Like you can have team one and then team two, or team two and then team one. So you divide that by two and you get 120. So that's how you do number one. For number four, you have to remember that there are repeats. So uh, many people got that 8 factorial equals 40,320, which is good. However, that includes every word 4 factorial times 2 factorial times, because O is repeated 4 times and K is repeated 2 times. So you just have to divide by 4 factorial times 2 factorial, which is 24 times 2, which is 4320, divided by 48, which should equal 840. So that's that problem. And for number five, this one people struggled a little bit more with, and uh, uh, hold on. Sorry. Okay. And for number five, you just have to think about how many choices you have for each way. And this is a lot more reliable than permutation because, first of all, permutation is essentially just doing that, and it's better to know the concept and not just know blind formulas. So, uh, if we start with the principal, he has three choices for where to park his car. Then for the first teacher, you can choose anywhere that isn't where the principal parks. So 8, and then the second one has 7 because it can't be in the two already occupied spots, and the next is 6, 5, 4, 3, etc. And you can multiply these out to get your answer, which is 60,480. So does anyone have any questions about these homework problems? If you do, please send a chat message. Uh, going to go on to the next problem. So now we're going to go over the AMC 8 review. This time seems to be harder than the last time, but a lot of people still did pretty well with scores that are nearing 20. So the problems we're going to go over are 3, 4, 6, 14, 21, 5, 11, 24, 15, 18, 8, 20, 12, 16, 17, 19, 23, 25. So those are just problems that a lot of people seem to have trouble with. And the ones that we aren't going to go over are 1, 2, 7, 9, 10, and 13. And their answers are E, E, C, and C. So if you have any questions on those, please tell me. Um, and we're going to go on to the next problem, number 3. So extend the square pattern of 8 black and 17 square tiles by attaching a border of black tiles around the square. What is the ratio of black tiles to white tiles of the extended pattern? So uh, for this problem, you essentially just have to be careful. So like if you're adding black tiles, then you're obviously not going to add any white tiles, and you already know that there are 17 of them. And the total number of tiles is going to be 6 times 6 equals 30. 7. Sorry, it's going to be 7 times 7 equals 49 because you're going to have a square that's 7 by 7. So if you have 49 total minus 17 black, it leaves you with 32 white. So the ratio of black tiles to white tiles would be 32 to 17. Some people put 36 to 17. I think that's wrong for 2 reasons. I think the first when the first method that went wrong was that when you add 1, it becomes a 7 by 7, not a 6 by 6. And then also you have to count. You're doing black to white, not everything to white. So, does anyone have any questions about this? I don't think there will be, so we're just going to go to the next one. So, number 4. Here's a list of the numbers of fish that Tyler caught in 9 outings last summer. 2013033312. What statement about the mean, median, and mode is true? Would anyone like to present this problem? And for people that just joined, we just went over the homework problems, and now we're on the AMC problems. And if you if you have any questions about the homework problems, I've recorded the meeting, so I'll try to post a link to that on Google Drive. So the first thing you want to do in this problem is to sort them in alphabetical order, which is 0, 0, 1, 1, 2, 2, 3, 3, 3, or numerical order. Sorry. And then from that, what you get is that the mode here is clearly 3. The median here is going to be the 5th number, which is 2. And the mean you can calculate, but you can add them up, and I believe you get 15 divided by 15 divided by 8, which is less than 2. So then clearly you can just get mean is less than median is less than mode. So the answer to this problem is C. So we're going to go on to the next problem, which is that in a town of 351 adults, every adult owns a car and a motorcycle or both. If 331 adults own cars and 45 adults own motorcycles, how many of the car owners do not own a motorcycle? So I think the reason why people got this wrong is that they misread the problem. It's how many car owners do not own a motorcycle, not how many car owners do own a motorcycle. So in that case, it's actually really simple because 351 minus 45, 351 minus 45 equals 306. And so 306 people do not own a motorcycle. But again, every adult must own a car, a motorcycle, or both. So what that implies is that all of these 306 people are also car owners. So the answer is simply 306. So does anyone have any questions about that? I'm going to continue. So the answer to this one was D. And we're on to number 14. So this one is just a bit of calculation. There are 270 students at Colfax Middle School, and the ratio of boys to girls is 5 to 4. There are 180 students at Winthrop Middle School, where the ratio of boys to girls is 4 to 5. The two schools hold a dance, and all students from both schools attend. What fraction of the students at the dance are girls? So uh, you add these, and you could get that there are going to be 450 total. And then at Colfax Middle School, there are 4 divided by 9 times 270, which is 4 times 30, which equals 120 girls. At Winthrop Middle School, it's going to be 5 divided by 9 times 180, which is 5 times 20, which is 100. So number of girls is going to be 120 plus 100 equals 220. And the answer is going to be 220 divided by 450, which equals 22 divided by 45. So the answer is C. Does anyone have any questions about that? So next is number 21. Students guess that Norm's age is 24, 28, 30, 32, 36, 38, 41, 44, 47, and 49. Norm says that at least half of you guessed too low, 2 of you are off by 1, and my age is a prime number. How old is Norm? So uh, for this problem, there are 2 methods that I'll go over. So the first one is simply going through the answer choices. This is a trick that you could use on the AMC 8 or 10 or other competitions where there are answer choices. But on competitions that there aren't, there are short answer questions like math counts, you can't necessarily do that. So if you just go through the answer choices, you can see that 29 is okay. 29. Not half of people guess too low. If half of people guess too low, then their age will be then Norb's age will be at least 36. So it can be 29, and for the same reason it can be 31. And you can just check that 37. It does in fact work. 2 people are off by 1. Which are the people who got 36 to 38? 37 is the prime, and it's more than half of the more than it's more than half of the guesses. At 43, you can see that only one person is off by 1, and 48 is not prime. So that's where you get that the answer is 37. And the other option is instead to sort of go through these numbers instead. Uh, and the important one here is that 2 people are off by 1. So what does this mean? That means that because no 2 people guess the same number, then we just need to find 2 guesses that are two numbers apart, and then the one that's in the center will be off by 1. So for example, 28 and 30 would work because 29 is off by 1 from 28 and 30. Similarly, you have 30 and 32, 36 and 38, and 47 and 49. And that leaves you with 29, 31, 37, and 48. And then you could proceed that like before. This is not prime and these are not big enough. So that's where you get your answer, which is 37. And this is how you would do it if you didn't have the answer choices. So does anyone have any questions about this? Not, we're going to continue on to the next one. Okay, what time was it? 2011 minutes after midnight on January 1, 2011. So this problem is mainly just the main issue people had with this problem is simply just having a bit of calculation error, because this problem does require you to be pretty careful. So first, remember that there are 60 minutes in an hour, and 2011 divided by 60, well, 33 times 60 is 1980. So this is going to be 33 hours plus 2011 minus 1980 is going to be 31. So 31 minutes after midnight. And again, 24 hours is 1 day. 24 hours is 1 day. So it's going to be 9 hours and 31 minutes after midnight of January 2. And the answer from there you can clearly see is going to be D, January 2 at 9:31 a.m. So does anyone have any questions about that? There's just a bunch of unit conversion. So you just have to be a bit careful. Okay, next one. The graph shows the number of minutes studied by both Asha and Sasha in 1 week. Given on the average, how many more minutes per day did Sasha study than Asha? So the way you want to do this problem is to look at the differences on each day. You could add them up and then add both of them up and then subtract them and divide by 5. However, that is simply a lot more effort. But if you want to do that and you think it's fine, then you can do that as well. So for the first day, you can see that's 70 minus 60, which is 10. On the second day, Tuesday, you can see that's going to be 80 minus 90, which is negative 10. On the next day, it's 120 minus 100, which is 20. On the next day, on the next day, it's 110 minus 80, which is 30. And then the last day, it's 50 minus 70, which is negative 20. And you add these up, you can get 30. It's even more convenient because these cancel out. So the average is simply going to be 30 divided by 5, which equals 6. Does anyone have any questions about this? Not then. Let's go on to the next one. Number 24. In how many ways can 10,001 be written as the sum of 2 primes? So this is more just like recognition problem, I guess, using the terminology. So actually, everyone who attempted this problem got it right, but if you didn't do it, then it can be hard to figure out. So remember that if an even number plus an even number, you get an even number. If you add an odd number and another odd number, you get an even number. And only if you add an even number and an odd number, you get an odd number. So 10,001 is odd. So what this means is that you have to add an even number and an odd number to get to 10,001. Well, it's known that the only even prime is 2, because anything else it'll be divisible by 2. So for example, 6 divisible by 2. But then that means that the other number has to be 10,001 minus 2, which is 9999, and this is clearly not prime. It's divisible by 3, 9, 11, and 101. So that means that there are no ways you can do that. Does anyone have a question about that? So it's kind of like you either see it or you So, number 15. How many digits are in the product 4 to the 5th times 5 to the 10? So, this one is not actually that hard. You don't have to calculate it out anything because 4 to the 5th, well, uh, because 4 to the 5th is equal to 2 to the 10. This is because this is equal to 2 to the 2 to the 5th, which is equal to 2 to the 2 times 5, using the exponent rules. And 2 to the 10 times 5 to the 10 equals 2 times 5 to the 10 because they have the same exponent, which equals 10 to the 10. So what does this mean? That means that it's going to be a number that starts with 1 and has 10 zeros. So like 10 to the first is just 10, is 1 0, 10 to the second is 100, and etc. And well, there's 1 1 and 10 0, so the answer would just be 11, which is D. Does anyone have any questions about that? So like whenever you see a problem like this one or the last one where it seems like a bit difficult to go through the like directly, then maybe think about other ways you could think about it. So the next problem is going to be number 18. A fair six-sided die is rolled twice. What's the probability that the first number that comes up is greater than or equal to the second number? So this uses a pretty common trick, which is that the chance that the first number is greater than the second number is equal to the chance that the first number is less than the second number. And that's just by symmetry. If I could roll 3 and a 4, then I could also roll 4 and a 3. So using that, then we just have to calculate how many what's the probability that they're equal. And the probability that they're equal is simply 1/6. Because either they're both ones, they're both twos, they're both threes, they're both fours, they're both fives, or they're both six. And that's 6 possibilities out of a total of 6 squared, which is 36. Or you could just think about it as the first number is anything, and the next number has to be equal to that, so it's 1/6. So what this means is that 5 6 are unequal, and again, by symmetry, that means that 5 12 have the first greater than the second. So again, if you have one possibility where the first is greater than the second, you can simply reverse them to get one where the second is greater than the first. So 3 4 and 4 3. So the probability that we're looking for is going to be 5 12 plus 1 6, which is equal to 5 divided by 12 plus 2 divided by 12, which equals 7 12. Does anyone have any questions about that? We're going to continue. Bag A has 3 chips labeled 1, 3, and 5. Bag B has 3 chips labeled 2, 4, and 6. If one chip is drawn from each bag, how many different values are possible for the sum of the two numbers on the chips? So there's two ways to do this. The first one, which I guess I wouldn't recommend, is to just add all of these. There are only 9 total possibilities because you have 3 from here and 3 from here, and just find the number that are distinct. But that's not the best way to do it. Because I mean, if you have like a lot more of these, then that would be pretty time consuming. Instead, note that again, because these are odd and these are even, the sum will always be odd. And the small sum they can have is 3, the largest sum they can have is 11. And you can actually get every number that's between 3 and 11. That's also odd because these are in increments of 2, so you can add 2, and then add 2, and add 2 by just incrementing these values. And so our possibility is 3, 5, 7, 9, 11 for a total of 5. And you can, if you're not convinced, then you can just go and verify that each of these is possible. So 1 and 2, 1 and 4, 1 and 6, 3 and 6, and 5 and 6. Does anyone have any questions about these problems so far? not, then we're going to continue into the next one. And if you really don't understand anything, please don't be afraid to ask. Quadrilateral ABCD is a trapezoid. AD equals 15, AB equals 50, BC equals 20, and the altitude is 12. What is the area of the trapezoid? So, does anyone have any ideas on how you do this problem?
I can try it. So if you know the height is 12, then you can split the trapezoid into like 3 different shapes. One is like a rectangle, like yeah, like that. And then to find the lengths that are extending from a like those lengths, you can use Pythagorean theorem, and then it's a 3, 4, 5 triangle on both sides. So one is 9 and the other is 16. And then you know the bottom base is 50 plus 9 plus 16, which is 75.
Yep.
And then
So,
you calculate the area of a trapezoid from there.
yep. Great job. This is how, like, you'll often see problems with the trapezoid where you have to calculate the values of sides and stuff based on the height, and this is always how you're supposed to do them. So you take the altitudes, or just uh, you can just think of it as just dropping the height from A and B, so that gives you these right angles. Because A, B, and C, D are parallel, because it's a trapezoid, then well, let's call these points E and F. It doesn't really matter. Then AE is going to be 12, BF is going to be 12. And then we can just calculate these lengths using Pythagorean theorem. So for this one, it's going to be the square root of 20 squared minus 12 squared, which equals the square root of 400 minus 144, which equals the square root of 256. And you can either just factor this or just memorize it to get this equal to 16. And on the other side, you have 225 minus 144. Again, those are the squares, which equals the square root of 81, which equals 9. So you got that this is 9 and this is 16. And then from here, you can use the trapezoid formula, or you can calculate this area of these shapes individually. So for the left one, it's going to be base times height divided by 2, which is 9 times 12 divided by 2, which equals 54 if you multiply it out. This side is going to be 12 times 16 divided by 2, which for this one, if you multiply it out, you're going to get 96. And then the middle rectangle is just going to be 50 times 12, which is going to be equal to 600. So you have 600 plus 54 plus 96, which equals 150. And another way you can do it is by using the trapezoid area formula, which is going to be the top base plus the bottom base divided by 2 times the height. So the top base is 50. The bottom base is 9 plus 50 plus 16, which equals 75. So 50 times 75 divided by 2 times h, which is going to be 12. So you can actually um, you can actually split this up and see that it's basically just a shortcut for this. But anyway, you can do this, and the same way you can get this. You can you can get the area of this the same way. Another thing that I want to point out, which talked about, is that um, yeah, which is that these are both 3, 4, 5 triangles. So what this means is that uh, 15 and 12, they're both multiples of 3. So if you divide 3 from both of them, that you get this is equal to 5 times 3 and equal to 4 times 3. And you know that 3 squared times 4 plus 4 squared equals 5 squared. This is the most famous Pythagorean triple, probably. And from there, you can just multiply each one by 3 to get that this is equal to 3 times 3, which is 9. In this case, you have 3 times 4 and 5 times 4, so this one's 4 times 4, which is 16. But either way, you can get the same thing. So just Anyone have any questions about this? And it's okay if you don't know some stuff down. Okay, so number 12. Angie, Bridget, Carlos, and Diego are seated at random around the square table, one person to a side. What is the probability that Angie and Carlos are seated opposite each other? So does anyone want to show how to do this problem? So for this one, then you can think of it two ways. So I think a lot of people are sort of overthinking it. But if you first just fix Angie to one side and think about the seating relative to her, then Carlos can be in either, and then can be in any of these three seats. And you can think of it, well, like all of these cases are symmetrical. Like they have the same options. So if C is here, then you can have either BD or DB. If C is here, you can either have BD or DB, and so on. So you can see that each of these have the same possibility. So it's just 1 out of 3. Alternatively, if you're not satisfied with that, you can actually calculate this. If you like consider Angie as like sitting on the left, then where there are 6 total possibilities to see the rest of them, which is just 3 factorial. And if Carlos is sitting here, there are 2 factorial ways. So you get 2 divided by 6, which is 1/3. So either way, you get 1/3. A lot of people put 2/3 for this problem. I think maybe that's because you were doing the other method with the factorial, but you have to remember there aren't 3 ways to see to all 3 of them. There are 3 factorial ways. So does anyone have any questions about that? By the way, I received a question on number 11, which is how can you use the Pythagorean theorem to find the answer to the last problem? So again, what you want to do is you want to drop the heights from here, and then these are both going to be 12. Using the Pythagorean theorem, because these are right triangles, you can find this length and this length. And because we know this is 50 and this is a rectangle, we can find the bottom length. And using that, we can find the area of the trapezoid. If you don't understand some of that right now, then don't worry. Uh, so don't really worry. You can look some stuff online. Okay, someone said you multiplied 1/3 by 2 because there are 2 ways the other 2 could sit. But in that case, then you can't do 1/3 times 2. You have to do 1/6 times 2. Because in the other situations, there are also 2 ways the other 2 can sit. So does that make sense? Like there, like I mean, there are 1/3 possibility out of these 3, but it's not going to be 2/3, as in this one has 2 out of those 3 possibilities. It has 2 out of 6 possibilities if we're just considering how all 3 of them can sit. So does that make sense? Like if you're multiplying by 2, then it's you're being inconsistent because the 1/3 is how many ways Carlos can sit, but the multiplying by 2 is how many ways everyone can sit. So does that make sense? Okay. So let A be the area of the triangle with sides of length 25, 25, and 30. Let B be the area of the triangle with sides of length 25, 25, and 40. What is the relationship between A and B? So this is one of the more complex problems in the set, and the way you want to do it is as follows. So, considering, so we have these these 2 triangles, right? Well, can't really draw, but you have like this, and you have it like this. I'm just drawing the height for each of these right now. So 25, 25, 25, and 25. Because these are isosceles, which means that two of them are the same side, and that this is, we're taking the altitude here, which is height, these two are going to be equal. That's just by symmetry. So in this case, it's going to be 15 and 15, and this is going to be 20 and 20. And well, actually, it should be the other way around, but it's not too important. And you can use you can either multiply all of these, multiply and find the area of each one by using Pythagorean theorem to find the height of this is 15 and the height of this is 20. By 25 squared minus 20 squared equals 15 squared. Just like the last problem. And then you can multiply these out to find the areas. But sorry about that. But that's not the best way you can do this. So the best way you can do this is by just taking a look at these triangles. This one has 25, 15, and 20. This one also has 25, 15, and 20. And we'll just take this as a fact right now, but you can prove this later. But especially, you'll learn about this later. Especially like actually, if three, how do I want to word this? If two triangles have the exact same side lengths, there are also some other other ways you can prove this. Like for example, if there are two sides and one angle that's in the middle of them, but we're just going to focus on that one right now. If you have if you have a triangle which has three of the same side lengths, they will be the same. They'll be the exact same. So what this means that their angles will be the same and their area is going to be the same, etc. This is called the two triangles being congruent. So these triangles are congruent, and I guess you can think of it as simply like flipping this around, but you can, well, from there you can just see that because this area is going to be equal to this area, and this area is going to be equal to this area, then the total areas for both will be identical. So let's see. So if that was a bit confusing, then don't worry about it. We'll get to it later. And in that case, you can just use the other way, which is simply to just multiply these out. Does anyone have any questions about this? Not then. Continue to the next one. Can you re-explain the pathway? Okay, so like in the other way, you want to draw the height from here down, and because these triangles are isosceles, which means that two of the sides are the same, and specifically these two sides are the same, then this will also bisect this side line, which simply means that it cuts it directly in half. So this will be 20, this will be 20, this will be 15, this will be 15, and then you use Pythagorean theorem to find the other one. So on this side, you end with 25, 15, and 20. On this side, you end with 25, 20, and 15. And these two triangles, they have the exact same side lengths. What that means is that they also have the exact same angles and the exact same area. Because they have the exact same area and each triangle has two of these, then what that simply means is that these triangles will both have the same area. So does that clear things up? Or do you still have any like specific questions about this method? Oh, let's go. Number 17. Let w, x, y, and z be whole numbers. If 2 to the w times 3 to the x times 5 to the y times 7 to the z equals 588, then what does 2w plus 3x plus 5x plus 7y equal? And actually, for the last problem, I received a question. How can the area of two triangles with different side lengths be the same if two are the same? Those triangles actually did have the same side length, 25, 15, and 20. They were just in a different order. So they are actually the same, completely the same. Like, do you mean like those two triangles, the 25, 25, 30 and the 25, 25, 40? Yeah, but we're splitting those in half. And in that case, you got 25, 15, and 20, and 25, 20, and 15, which are the same. You can have cases where two triangles that have different side lengths have the same area if two of them are the same, and this is just one of them. You can calculate the area using many different methods, and you'll still get the same result. It's a bit weird, but that's just how it works. Like, number 17. So there's a theorem called the fundamental theorem of arithmetic that we're not going to go over right now, but it's kind of just common sense. So what this means is that 588 is going to be represented as the product of primes in only one way. So it's more just intuitive. And this is true for all numbers. Like, for example, 12 equals 2 times 2 is 3, but it can't have any other way of being multiplied by a prime, or being a multiplication of primes. And I mean, you can change the order, but that's all you can do. So what this means is that there's only, like, we just have to take the prime factorization of 588. 588 is divisible by 2. Well, it's also divisible by 4, as you can tell. So we're just going to do that. 588 divided by 4 is going to be 4. Put this down. That, yeah, it's 147. And 147, you can either memorize what this is, or you can just divide by 3, because you can add these and it's divisible by 3 to get this is equal. This is going to be equal to 3 times 49, and 49 is 7 squared. So it's 4 times 3 times 49, which is equal to 2 squared times 3 to the 1 times 7 squared. And remember that 5 to the 0 equals 1. 0 is a whole number, so we are allowed to do this. So it's going to be times 5 to the 0. And essentially this term is not going to matter at all. So yeah. So you can so you can do here is that you just multiply. So 2 times 2 plus 3 times 1 plus 5 times 0 plus 7 times 2 is going to be equal to 4 plus 3 plus 14, which is simply equal to 21. Where did I get 12 from? That's just an example. This is just an example. It's unrelated to the problem. It's just to show that like a number can only be a number can only have one prime factorization. So actually, since we're halfway through the class, then we're just going to take a small break right now. So you can turn off your cameras if you want. We'll come back at 11:07. All right, it is 12. Well, it is 11:07, so please turn your cameras back on. So we have 4 more problems to get through, and then we can talk about counting. By the way, we will be extending class to 11:45 because we started late. So sorry about that. Uh, you can, if you have to, if you really have to leave at 11:30, then you can, because I'll still have a recording for you. And um, for the next few weeks, if I don't get the issue with my school account fixed, then we'll continue on this. We'll continue on this Zoom meeting. So uh, I'll get further information about that later. But anyway, number 19. How many rectangles are in this figure? So people seem to have a little bit of trouble in this one because, well, you just have to do some really careful counting. So for this one, it's a bit hard to choose cases to do casework with, but one option you have is to do it uh, by considering each of these as like a region, and then looking at how many of each region are in one. So for one region, you can have this one, or this one. Those are the only 3 perfectly rectangular regions. For 2 regions, let me use a different color. You can have this one, this one, this one, this one, or this one. So that's a total of 5. And you can check. You just really have to be very careful to check that those are in fact the only ones, but um, you can just do that. There are none of them that have 3 regions. Uh, well, you can check this again, but like anything you choose that has 3 regions, it'll have to like poke out a bit or something like that. And then for 4 regions, you can. There are 3, which are just these big rectangles. And for a total, you get 11, which is D. Uh, Another way you can do this problem is, I guess, to instead think about how else you can represent this. So you notice that this is sort of the same as um, never mind. Yeah, never mind. But this problem, you just have to be really careful and make sure you don't miss anything. Yeah, that's about it. Next thing, uh, it was number 20, 23, number 23, uh, okay, number 23. Uh, okay, how many 4-digit positive integers have 4 different digits, where the leading digit is not 0, the integer is a multiple of 5, and 5 is the largest digit? So we'll use casework on this. We know that it's a multiple of 5, so what that means is that either it ends in a 0 or ends in a 5. So case 1 ends in 5. So from here, from here, these 4 can be anything as long as they're less than 5. Well, the first one, it can't be 0 as stated, so this can be 1, 2, 3, or 4. This one can be 0, 1, 2, 3, or 4. And this one can be 0, 1, 2, 3, or 4. So for this case, you have a total of 4 times 5 times 5 equals 100 options. Uh, Actually, sorry. This is incorrect because you have 4 different digits. So you actually you have 4 choices for the first one because you can't have a 0. For the second one, you can have a 0, but what you can't have is what it was in here, so 4. And for the third one, you can have the first one. So for the third one, you can have anything where that's not the first two digits. It can still be a 0, and of course you can still not be 5. But that gives you a total of 48 for this case. For the second case, which ends in 0, we know that the largest digit is 5, so one of these has to be a 5. So let's just choose the 3 digits that are in here in no particular order. We know that a 5 has to be one of them, and then for the other two, we can choose any 2 numbers that are not 0, that are not 5. So you have 4 options for the first one, 3 for the second one, but right now we don't care about the order, so that's 6. And this is 4 choose 2, if you remember, because you have 2, you have to take 2 of them from 4. And then you have 6 options for that, but of course, just because, like for example, if you choose 1, 2, and 5, you have 6 options for this one, 6, which is 3 factorial, because you can swap these three numbers around no matter how you like. So 6 times 6 equals 36, and you can add these. 48 plus 36 is equal to 84. Say, does anyone have any questions about that? Number 23 is D, which is 84. And yeah, a lot of these problems, it really helps if you just spend an extra few minutes to either check your work or just or spend the time to make sure to like reread the questions a few times. Because for several questions it can be hard. It can be really easy to misread them and get an incorrect answer. So, oh, sorry about that. Number 25. A circle with radius 1 is described in a square and circumscribed about another square, as shown. What fraction is closest to the ratio of the circle's shaded area to the area between the two squares? So, well, there are a few ways you can do this. The first one is just by using common sense, right? So, we're looking at, well, because we're sort of looking at the difference between this area and this area. So, it's like this area versus this area. And it's actually 4 times each one, but if you multiply them by 4, that doesn't affect the ratio. And, well, obviously this one cannot be bigger than this one because it's completely contained within that one. So that means that these answers are out. And if you just look at it, it looks like it could be about a half, but it's definitely not like a large majority of it like that. So that just leaves you with 1/2. So you can, on the real exam, you could just take a guess on this one if you don't have time to do it properly, and if you guess it, then you'll most likely be correct. Just taking a look at it. But of course, if you want to do this properly, then you should just actually try and solve this. So you get just 1, and therefore that this whole thing is 2 because that's the diameter. The area of the outer square equals 4. The area of the inner square equals 2. So you can either you can think of this in a few ways. You can either like just if you draw these lines, and you can see that this is equal to this, this is equal to this, this is equal to this, this is equal to this. So it's going to be half of the base square. Or alternatively, you could use this Pythagorean theorem to get this as root 2, and then root 2 squared is going to be 2. But no matter how you get it, then you can get the inner square is going to be 2. So the area between the two squares is going to be equal to 2. The circle's shaded area. The area of the circle is going to be pi, which is 1 squared times pi. But the shaded area is going to be that minus the inner square, which is equal to 2. So pi minus 2. We can just do a bit of estimation for this one. This is about 1.14. This, well, 3.14. This is about 2. 3.14 minus 2 is 1.14. And 1.14 divided by 2 is, of course, very close to 1/2. Someone said I did it and got about 1/4. Can you elaborate on what exactly you did? Because, um, like, I'm, um, like, it's possible that you miscalculated the area of the inner square, and in that case, you would get something that is, I guess, closer to. Okay, yeah. Um, well, essentially, you can either just take a look at it and sort of estimate, or you can just take a look at it properly. Yeah, root 2 squared is, the area of the inner triangle, the inner square is 2. And again, this problem you can just use a bunch of guesswork, I guess, because this is pretty clearly half of the entire square. Number 22. This is the last problem we're going to go over. What is the tens digit of 7 to the power of 2011? So, this problem simply relies on pattern checking. So the tens digit is going to be affected by the units digit and the tens digit. So the 7 to the 1 is going to end in 0, 7. 7 squared is going to end in 4, 9. 7 cubed is going to end in 4, 3. 7 to the 4th is going to end in 0, 1. You can do this by just multiplying each one by 7 each time. Obviously, since you have 7 here, 0, 1 here, if you multiply by 7, you get back to 0, 7. And what this means is that the pattern repeats. So 0, 1, 0, 7, then 4, 9, then 4, 3, and then 0, 1, 0, 7, 4, 9, 4, 3, etc. So this, you can see here that it really, it only matters on, it really, just repeats. So this problem is just about looking for patterns. You could do this like in other methods, but that would be a lot more confusing. So this method, it just works. So what this means is it repeats every 4. So 2011 divided by 4 is equal to 502 plus some numbers, plus 3, but it doesn't matter. But that's what you care about. But anyway, I guess one way you could think about this, sorry, is that it repeats every 4. The largest multiple of 4 that is less than 2011 is 2008. So that means that 7 to the 2011 will have the same tens digit as 7 cubed. 7 cubed tens digit is 4, so this one's 4. So everyone who attempted this, everyone who got this wrong, got A. If you are one of those people, can you like explain how you got 0 in the chat in a private message? Because then, like, it seems like a pretty common mistake people are making. So I think it would be helpful if you like told me how you got it and how you could not have it, and how you like and what the error in that is. Like, I guess maybe one mistake you might make is that because it's like the tens digit, then and like we're in base 10, then it's going to 7 to the 1. But that logic doesn't work out if you just look at the patterns. Like, for example, 7 to the 11 is 4, and you included 5 to the 5th as part of the pattern. 7 to the 5th. Okay, yeah, that's a pretty common mistake. So the pattern, it repeats every 4, not every 5. And you can think of this as 7 to the 5th equals 7 to the 1st. Well, 5 equals 1. for the tens digit. And 6 equals 2, 7 equals 3. So it's just, you subtract 4 each time. So you just have to be careful with that and sort of just check it. So yeah. The Does anyone have any questions about the AMC 8 problems? If not, then we're going to continue on to counting. I'm going to start with a brief review of combinations. But so combinations. So what is a combination? We're going to go over this again. A combination is like a permutation, but order doesn't matter. So C of n comma r and NCR, those are the different symbols, as well as this one, which is arguably more common, but they represent the number of ways you can choose R things from n objects that don't have an order. And you can find a formula from these, but again, it's it's better to just think about how that works. So Roger has won a contest at the fair and gets to choose 4 different prizes from a set of 9. How many options does he have? So this is going to be 9 choose 4, and you can think of it as follows. So 9 choices for the first one, 8 for the second, 7 for the third, and 6 for the fourth. But you can choose these in any order. So you have to divide by 4 times 3 times 2 times 1, which is the number of ways you can arrange these. And you can cancel and get this equal to 9 times 2 times 7 equals 126. There are 15 people in the class. How many ways can they form a 4-member committee? And again, 15 times 14 times 13 times 12 divide by 4 times 3 times 2. So what this represents is 15 choices for the first member, 14 for the second, 13 for the third, and 12 for the fourth. But these members can be in any order they want. So we have to divide by the factorial. And if we do that, then we can get this equal to 15 times 7 times 13, which is, 15 times 91, which, which is equal to 1365. Anyway, we're going to go on, but we learned about this last class, so we're going to go on. This is a formula, so just what is 5p2 times 5c2? Alternatively, you have you have 5 students. One of them has to be the vice president, one of them can be the president, and 2 of them have to be council members. And a president or a vice president can still be a council member, and they can also not be a council member. How many options do you have? So 5p2 times 5c2. So it's simply 5 times 4 times 5 times 4 divided by 2 is 20 times 10 equals 200. So does anyone have any questions about the concepts behind combinations and permutations? Okay, looks like people should understand it, and the next problem is going to be grid paths. So, in 1 minute, in 1 minute, you can travel 1 line segment on the grid. Okay, can you go back to the formula? Again, the formula doesn't matter, but here it is. Well, it does matter, but it's more important to just think about it. Another way you can write it out that doesn't use factorials is something like n choose r equals n times n minus 1 times n minus 2 times all the way up to n minus r plus 1 divided by r factorial. This is, I think, a better way to do it. How did you get 5 times 4 for 5p2? It's simply 5 for the first choice, 4 for the second. And again, or you could get this equal to 4, 5 times 4 times 2 times 2 times 1, divided by 3 times 2 times 1, if you want to use the formula. So that's how torics and combinations and permutations work. So we're going to look at one application of combinations right now, which is grid paths. So grid path problems are ones that are like the one on the right. So okay, in 1 minute, you can travel one line segment on the grid. How many ways are there to get from A to B in 7 minutes? And you can see these problems expressed in many different ways. Like for example, you could think of it as being like, how many ways can you do it when you only move right and up, which that's like, or like how many ways can you get there the fastest? These are all equivalent. But there are, I guess, 3 main ways you can take a look at this problem. So the first way you can consider it is rearrangement. So like, I guess this is more, this is like sort of like the word orders from before. So you have to move right 4 times and up 3 times to get to to get from A to B, and this is just clear from how the grid is set up. And so every 7-minute path is going to have 4 U's, 4 R's, and 3 U's. If we represent every right move with an R and every up move with a U. So this just means that how many ways can we rearrange the letters in R, 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 U, U, U. So because like as long as you have 4 R's and 3 U's, it doesn't matter the order, you still get to B. So what this means is that using the formula from before, or just the logic, it's going to be 7 factorial because that's the number of ways you can rearrange them, but the number of ways you're overcounting each one is going to be 4 factorial for the R's and 3 factorial for the U's, which is 4 factorial, 3 factorial, which is, well, these cancel out and that cancels out with that, so you get 35. Another way you can consider this is that you have 7 moves in total. Out of these 7 moves, 3 of them have to be up. The other 4 are automatically right. But what this simply means is that we just have 7 choose 3 possibilities of where to choose the up moves. So that means that it's equal to 35. Again, 7 times 6 times 5 divided by 6. If this is a bit confusing, then this is how you can think of it. So you have sort of 7 minutes, right? So so we want to choose 3 of this minutes to move up. So let's say we choose this one, and this one. So there are 7 choose 3 possibilities of choosing the minutes that we go up. The other ones we have to automatically fill in with R's, and this is how we get a working path. And the third way is addition, which is not recommended for this problem, but it's useful for other problems like this where you have restrictions. So notice that this, so like for example, how many ways can I get to this square? I can only get there by going right and up, of course. Like actually, well, you have one way to go here. How many ways can we go here? It's only one, which is that way, because you can't go up and then back down or left or anything. And then we can fill these in similarly. And then let's consider this one. How many ways are there to get to this one? So it's simply 1 plus 1. Does everyone see why? Because we're doing the shortest possible, you can only move right or up. So if we move right to get here, that's 1 possibility. And if you move up, that's 1. So that's 2. And this one, there are 3 ways to get here. Like this, and like this. And you notice that 2 of them correspond to going right from here, and 1 of them is from here. So essentially, This is how you can get them. So this will show something that this is like interesting about or like related to later. But right now, you just consider them as just adding them, and you can see that you got 35. So does everyone understand all three methods of finding these grid paths? Or does anyone have any questions about why like these methods work or why other methods don't work? Can you do one again? Okay. So, based on the way the grid is set up, we have to move right 4 times. And then we also have to move up 3 times. So, that means that we have to rearrange the letters in R R R R U R U U U. And like you can think of each rearrangement as a path, and like for each path, those are the moves you're going to take. And then from there, it simply becomes 7 factorial for the total number of possibilities divided by 4 factorial since the R's are repeating, and 3 factorial for the U's are repeating. So 5040 divided by 24 times 6. Does that make more sense? Now we're going to go on to the next part, which is that you can use combinations instead of case root for seemingly complex problems. How many distinct rectangles are there on this grid? So this is similar to one of the homework problems we had today, which is how many rectangles are on this grid. But of course, this one's more complex, and you don't want to use case root for this because there are going to be so many different options. And in fact, a few people actually asked, are there like any ways that you can do this easier? And here's one of them. So, like, if you think about how a rectangle is formed on this grid, right? So, let's take, for example, an arbitrary rectangle, like any of them. So, this one. So, you can consider it like this. So this is a rectangle, but this is also a rectangle, and so is this, and this, and this. So let's just choose if we just choose 2 vertical lines and 2 horizontal lines. So for example, if we choose this line, and then this line, and this line, and then we just draw these out, we will always get one rectangle that is bounded by all these 4. In this case, it's this one. And every rectangle can only be every rectangle always has like these 4 lines, and which are just like the different sides if you extend them. Simultaneously, it can't have more than these because like it only has 4 sides. So what this means is that this problem is equivalent of choosing 2 of horizontal lines and 2 vertical lines. So in this case, it's 4 choose 2 times 7 choose 2, which is equal to 4 times 3 divided by 2, 7 times 6 divided by 2. These cancel. 2 times 3, which is 6. 21. 6 times 21 is 126. And we can confirm that this works using a smaller case for this one. We have, again, we want to choose 2 vertical and 2 horizontal. We have 3 vert here and 4 horizontal here. And we already know the answer to this one will be equal to 18, but let's check again. 4 choose 2 to choose the horizontal lines. 3 choose 2 to choose the vertical lines. 4 times 3 divided by 2. 3 times 2 divided by 2. That cancels, and you're left with 3 to 6 times 3, which is indeed equal to 18. Does anyone have any questions about this? Like, um, what does 4 choose 2 means? That's equal to that's just 4c2, or it's just it, 4 choose 2 is just this, which is the same as like it's just shorthand for like saying the 4c2 or this. It's just it's just like the combinations of choosing 2 for 4. Just distinctly different size, not in this case. If it did, then it would be pretty easy because you could just choose any width and any height. So, I'll let you try this problem or think about it. How many triangles can be formed by connecting 3 of these points? And note collinearities. What this means is that if I select these 3 points to be our vertices, you don't make a triangle, you make a line. You don't want that. So, yeah, everyone just think about this. Okay, why is there only 18? There are only 18 because that's for this problem, the homework problem, which we did get 18 on. I know it's a bit confusing because like this is actually does have 18 squares, but yeah, it's just to show that it works with the small example. So, uh, are we not doing the big one? We just did the big one. So we just choose 2 vertical ones and 2 horizontal ones. So in this case, those are these 2 and these 2. And what this means is that uh, we have 4 choose 2 options for the 2 horizontal ones, 7 choose 2 for the vertical ones. 4 choose 2 times 7 choose 2 equals 6 times 21 equals 126. For the triangle ones, I'm just going to go over it now since we're sort of running out of time at this point. Um, but so how many triangles can be formed by connecting 3 of these points? So the first thing you want to do is just to select 3 points. So let's say these. You can count that there are 11 total points here. 5 plus 6 equals 11. So the number of sets we can choose is 11 choose 3. And of course, we're taking combination and not a permutation because it doesn't matter if we're selecting this, this, and this, or this, this, and this, or this, this, and this. So 11 times 13 is 11 times 10 times 9 over 3 times 2 times 1. Okay, I'm sorry, but this is 5, this is 3, this is 15, so this is 165. However, not all of these are going to be triangles. Like I said, that is going to be the case when, for example, you choose these 3 and then you just form a line. And those cases are actually the only cases in which you don't form a triangle, which is when you like have a line instead. So, how many of these are there? Well, if we're connecting 3 points that are all on the top row, then that won't work. Those are 5 choose 3 ways to choose 3 points from the top row. 6 choose 3 ways from choosing 3 points in the bottom row, which will also not work. 5 choose 3 is equal to 5 times 4 times 3 divided by 3 times 2. That cancels, equals 10. 6 choose 3 is going to be 6 times 5 times 4 divided by 3 times 2. That cancels, you end up with 20. So it's going to be 165 minus 10 minus 20 equals 165 minus 30 equals 135. So that's going to be our answer for this one. And actually, we used a technique that we're going to go over later, not today, which is called complementary counting, which is essentially you choose you find for finding the number of possibilities where A happens, you find the total minus the number of possibilities where A doesn't happen. So what do I mean by that? In this case, the total number of possibilities with 3 to choose any 3 points was 165, but we use complementary counting by subtracting the number of possibilities where they don't form a triangle. So uh, essentially, yeah. So we're going to, yeah, because we're running out of time today, we're not going to get through all of this, but essentially, we find the total number of outcomes and subtract the ones we don't want. I received a question on this one. Why is it 6 times 5 times 4 and not 6 times 5 times 4 times 3 times 2? That is because because we're taking a combination. So uh, just think about, like, don't get caught up with these formulas because it's easy to make a mistake. Like for 6 times 5 times 4 times 3 times 2, that would be taking like a permutation, but we're not doing that. 6 times 5 times 4. The reason why we have that is because we have 6 options for the first one in these, 5 for the second, and 4 for the third. So we're just choosing 3 points. And then we divide by the number of ways you can rearrange them, which is 3 factorial, which is 6. So does that make sense? Does that clear things up? So then, uh, okay, 6, 5, and 4. So, okay, just think about how we're going to choose 3 points from these 6. So, we have 6 options to choose the first point. Let's say we choose this one. Then we have 5 for the second one. And then we have 4 for the third one. So, for example, this, and this. So those are the possibilities. You can choose any 3 points from these. And then we want to divide by 3 factorial because those are the ways you can repeat. So, I mean, if you still don't understand it, then I recommend you to either like go on AOPS and maybe and just look for some material, or I mean, you can try. You can ask me on Google Classroom after class, but that good at. I'm not really that good at explaining. Or you can go, or again, a good resource is the Art of Problem Solving website. They have forums. If you sign up, you can ask questions, and people will often help you and answer. And it's just a good resource. Well, anyway, it's 11:45, so if anyone does not have any questions, then you can leave the Zoom room. So see you next week.